Lesson 4, the identity and inverse elements. The identity element. Given a non-empty set S which is closed under a binary operation asterisk, if there exists an element E, member of the set S, such that A asterisk E is equal to E asterisk A equal to A for all A member of S, then E is called an identity element or a neutral element in set S under the operation asterisk. So here you do a kind of closure property and ensure that it is equal to the element A, which is a member of the given set. The neutral element E, if exists in S, is always unique. The inverse element. Consider a non-empty set S which is closed under a binary operation asterisk. If S is a member of the set S and an element S inverse member of S, such that S asterisk S inverse equal to S inverse asterisk S equal to E, where E is the identity element, S inverse is the inverse element. If S inverse is in the set S, it is unique. Here also you do a kind of a closure property and ensure that it is equal to the identity element. Examples number 5. A binary operation asterisk is defined on the set arrow of real numbers by A asterisk B equal to A plus B plus AB, where AB are members of arrow. Roman figure 1. Calculate 5 asterisk minus 2 asterisk 5. Roman figure 2. Find the identity element E of arrow under the operation asterisk. Roman figure 3. Determine the inverse element under the operation asterisk of a general element A member of arrow and state which element has no inverse. Solution. This is the given operation. We are asked to find this. To do this, you take the first two elements, that is 5 and minus 2, because we have AB in the given operation. So taking 5 asterisk minus 2 means A is equal to 5, B is equal to minus 2 in this expression, and you have this result. That simplifies to 5 minus 2 minus 10, that is minus 7. If you take everything together, you therefore replace these two elements by minus 7, then asterisk the third element. With this, A is equal to minus 7, B is equal to 5. You come here and replace them, you have this result. That is minus 7 plus 5 minus 35 equal to minus 37. Roman figure 2 of the problem, we have to find the inverse element. Remember, this is the given operation. In the question, we were told that there is a general element A, which is a member of set arrow. So let E be the identity element. Then A asterisk E is equal to E asterisk A and is equal to A. You take the first part. You simply come here and replace B with E. So you have A plus E plus AE. Then you equate it to the element A. From here, you can transfer A to the other side. There is a common element E here. So you have E plus AE equal to A minus A. When you transfer this one, it becomes negative. From here, you can factor out E. You have these results equal to 0. To get E, divide both sides by 1 plus A. When you do that, you have 0 as the identity element. Roman figure 3, the inverse element. The inverse element of A is A to the power of minus 1. The condition for inverse is A asterisk inverse of A is equal to E identity element, and that element is 0. So you have A asterisk A inverse equal to 0. Let's call that equation 1. To continue, you have to substitute A inverse into the position of B in the defined operation. That is, you come here, A is equal to A. Now, B becomes A inverse. This is the operation. You replace B with A inverse, you have it in this form. Let's call that equation 2. If you check both equations, they have the same left hand side. By implication, the other sides are also equal. So you equate this side to 0 in this form. You can transfer this term to the right. It becomes minus, while you have these two terms on the left. If you factor out A inverse, you are left with this result equal to minus A. To get A inverse, divide both sides by 1 plus A. You have it in this form. You are also asked to find the element without inverse. Such an element is the element that will give us undefined. In other words, which value will A assume for us to have 0 here? Once you have 0 here, it becomes undefined. The element without inverse is minus 1, because if A is equal to minus 1, the denominator of A inverse becomes 0. The result will be undefined. End of lesson 4.